Good morning, everybody. Welcome back to today's video. So today we're going to be talking about oxidation numbers and specifically how do we assign oxidation numbers to an atom. So just a little quick summary of what oxidation numbers are. Oxidation numbers tell you what's happening to the electrons within a reaction. So most of you probably know by this point in time, you start with your reactants and you end up with products. During that point in time, particularly in redox reactions, the electrons from one atom gains electrons and another one will lose electrons. So it's important to know what's happening in that particular moment with those atoms in a redox reaction so you know which side is gaining electrons and who's losing electrons. Hopefully that makes sense. Anyway, there's some very basic rules that we're going to start with. The first one is an atom by itself is always zero. It always has an oxidation number of zero. So something like iron, magnesium when it's by itself, H2, Cl2, all of those things are by themselves. So they always have an oxidation number of zero, which when you've got so if you have, say, Na plus Cl2 goes to form NaCl, hopefully you can see pretty clearly that both Na and Cl in the reactants have an oxidation number of zero, but when they're combined, they're not going to. So one is going to be losing and one is going to be gaining, and that'll clearly show in the oxidation numbers. Anyway, next, if the compound is neutral, so say H2O, it has a charge of zero. It has no charge at all. So overall, its oxidation numbers need to equal zero. A charged compound, so say OH minus, is equal to its negative charge. So -1 equals OH minus's oxidation numbers. Hopefully that makes sense. Group 1 and 2 metals are always +1 or +2. Fairly easy. Fluorine is always -1. Hydrogen most of the time is +1, but it can be -1 depending on the molecule. And oxygen is pretty much always -2, but when it is in H2O2, it becomes -1. But that's the only case that I think that you even have the chance of getting as an example on your external exams. So just remembering it should be around about -2. Now, these rules, these will remain the same every time that you are doing an oxidation number, trying to find one. This is what it's going to be. By the end of year 12, when you get to your external exams, this should all be instinctual. You should be able to work out the oxidation number without even thinking about it. But at the moment, it might take a little bit of time. Anyway, let's do some practices. So H2 is by itself. That means going to rule number 1, it must equal 0. So when we write oxidation numbers, we put them at the top with a plus or a minus or nothing if it's a 0. So that is H2. Let's move on to Al2O3. So we know that oxygen is -2. So I'm going to write that one down. We also know that this molecule does not have a charge, so we're going to put a 0 at the end there. And then we're just going to write out this molecule so that we can kind of see what's happening. So Al has 2 atoms in this, so it's going to be Al times 2. Plus, and oxygen has 3 molecules in there. So O times 3. Pretty easy step. After that, we are going to substitute in our values. So we don't know what Al is. So it's going to be an X. So it's going to be X times 2. And oxygen, we've already said, is going to be a -2 times 3. So there we go. We've got oxygen equals 2X minus 6. 2X minus 6. So from there, what we do is we're going to have a +6 on both sides to get rid of the 6 over here. So they'll get rid of both of those. And that'll give us +6 equals 2x. That's not a 2. Yeah, close enough. From there, we just, same thing, get rid of the 2 by dividing it by 2. So that'll get rid of both of those. And put a divider by 2 over here, which will give us with +3 equals x, which is what we know is our Al. So that means our Al is going to be +3. Now, this is a good time to just check your results. So we got +3 times 2 plus -2 times 3 equals positive 6 minus 6 equals 0. So that's what we want. So that's good. Oops. Okay, so that's our first example. Now we're going to go on this one here. So very similar concept, but this time we have a negative charge. So instead of starting with a 0, we're going to have a negative 3 equals. Same thing. We've got 1 phosphorus plus oxygen times 4. We're going to sub in our values. So negative 3 equals x plus negative 2 times 4. So negative 3 equals x minus 8. And then add 8 to both sides. Oops. And then we will end up with positive 5 equals x. So then we write up our answer. So phosphorus is positive 5 and oxygen is negative 2. Quick check. Positive 5 minus 8 equals negative 3. Perfect. So that's what we want. All right. So give this one a quick go by yourself. Pause the video, give it a quick go, and then come back once you're finished and we'll see how you went. All right. So we have a negative 2 for oxygen. Magnesium is in group 2, so it's got a positive 2. Carbon we don't know yet. We know it's neutral, so it's going to be equals 0. And we're going to write out our formula. So Mg plus C plus O times 3. Let's substitute our values. We've got positive 2 plus x plus negative 2 times 3. So 0 equals positive 2 plus x minus 6. So add 6 to both sides. Boom, boom. So that means we've now got positive 6 equals positive 2 plus x. Get rid of the positive 2 by minusing 2 from both sides. So 6 minus 2 is positive 4. Or negative 2 plus 6 is positive 4. Either way that works. We've gotten rid of those. So positive 4 equals x. So then above the carbon we will write positive 4. So hopefully you got that right. If not, hopefully you can see where you went wrong. Let's do a few more practices. So AlOH3. Again, give this a go before you watch this section. So pause the video, give it a go. So hydrogen's always +1, oxygen's always -2. There is no charge and we don't know what aluminium is. So let's just get started. So 0 equals aluminium plus O times 3 plus H times 3. Substitute in our values. Oh, that's so. So x plus -2 times 3 plus positive 1 times 3. So 0 equals x minus 12 plus 3. No, that's wrong. What did I just do there? I'm a genius. That's meant to be 3. Can't copy things down. So x minus 6 plus 3. It's a little bit better. All right, so let's start by getting rid of the 6. So that and that are going to get rid of, and then plus 6 on this side. So we have positive 6 equals x plus 3. And then we're going to get rid of the plus 3. So negative 3 from minus 3 from both sides. Negative 3 plus a positive 3 is, negative 3 plus positive 6 is going to be positive 3 equals x, because those are both gone. So aluminium in this case, again, is positive 3. So check if you got it right. If you did, that's great. If not, hopefully you can see where you went wrong. Let's try another one. So sodium sulfate. So sodium is a group 1 metal. Oxygen is -2, and we don't know what sulfur is. There is no charge, so again, it is a 0. Most molecules you'll come up with will be 0. So Na times 2 plus sulfur plus oxygen times 4. And let's copy it down correctly this time. So positive 1 times 2 plus x plus negative 2 times 4. So 0 gives us positive 2 plus x minus 8 this time. I don't know why I've got the brackets on the 2, but we're going to leave it, so that's fine. All right, so let's start. We'll add 8 to both sides. That'll get rid of you guys and make positive 8 over here. So positive 8 equals positive 2 plus x. And then we will minus 2 from both sides. Negative 2 plus 8 will give us a positive 6 equals x. So in this case, our sulfur molecule is going to be a 6, positive 6. Now, it's very important that you do include those positive numbers in there, because otherwise it will be classified wrong if you just put, say, 3 instead of positive 3. All right, let's go again. So again, neutral charge. So equals 0. We've got lithium times 3 plus a phosphorus molecule plus oxygen times 4. So starting by substituting our values, we know lithium is a +1 metal and we know oxygen is negative 2. So we can put both of those in there straight away. +1 times 3 plus, don't know what phosphorus is, plus negative 2 times 4. So 0 is equal to positive 3 plus x minus 8. So same thing as before, positive 8, get rid of both of those. So we end up with positive 8 is equal to positive 3 plus x. And we're going to minus 3 from both sides. Negative 3 plus 8 is going to give us positive 5 equals x. So our phosphorus has a oxidation number of positive 5. All right, lucky last, calcium nitrate. So give this one a go. It's a little bit more tricky than the other ones, I think, possibly. But try it anyway. Anyway, calcium is a group 2 metal, so positive 2. And oxygen we know is minus 2. So 0 equals, we've got 1 calcium plus we have 2 nitrogens plus we have oxygen times 3 times 2. So substituting in our values, we have calcium is our +2 plus n times 2. So that's going to be 2x plus oxygen, which is negative 2 times 3 times 2. All right, 0 equals positive 2 plus 2x. Well, that would be a minus. So 3 times 2 is 6. 6 times negative 2 is negative 12. So we're going to start by adding 12 to both sides, which is going to give us positive 12 equals positive 2 plus 2x. And then we are going to minus 2 and minus 2. And that'll give us positive 10 equals 2x. And our last step, we are going to divide by 2 on this side, get rid of those, and divide by 2 on this side, and that is going to leave us as positive 5 equals x. So in this case, our nitrogen is going to be a positive 5. So I hope that made sense. I hope you had some success with that. If you have any questions, you can leave them in the comments down below. You probably should be doing a bit of practice on this, but even more so when you have things like balanced equations that you need to do, that is the perfect time to practice this skill over and over again, so that by the time you get to the externals, it is completely in your memory and you don't even have to think about it to get it done. Anyway, I hope you guys have enjoyed. If you did, please like the video and I shall see you in the next video. Bye.